Hi, everyone, and welcome to our next session here at PyData Global. Please feel free to use the chat to connect with fellow attendees and share your thoughts during this session. If you do have any questions, please post them in the Q&A tab, and we'll address them at the end of the session. Now, it is my absolute pleasure to introduce you to Tim Spann, who is a principal. And if you all would be so kind, let's give a warm virtual welcome to Tim. Take it over, Tim.
Okay, thanks a lot. Um, just let make sure everyone's on there. And today we have a longer session, so feel free to put in questions or just mention things in the chat if there's things you want me to go deeper into, or if there's additional information you need. We have a very long session, which is pretty awesome. So we should have time to do things, and we should have time to wait if you're trying to code along. So today it's a tutorial. It's called It's in the Air Tonight, Sensor Data in RAG. And we'll cover how we get data, some different options there, some popular frameworks we're using, how we're doing this all in the open source, and all the different things that you could do with some different technologies, and we'll provide you as in depth as possible. Now, to make it easier, I already uploaded my slides, and I know PyData will have them online as well, but you could either scan the code or grab that bit.ly, and that will link you to a slide share of all the slides that were covered today, give you a little time to go over this. And again, if you're watching this at a later date and not live in December of 2024, they'll still be there. And we'll make sure you get all the other contact information, where the GitHub is and all that sort of thing. But I'll make sure you get the slides. So if you want to jump ahead, again, if you're trying to code along, you could do that. And I'm going to show you some other examples with more 101, how to do the most basic RAG just to get used to it, get started, and then you could start swapping out things here and there. And there's a lot of places where you can make options, and we'll try to take time there again because we have a double session here, which is interesting. I haven't really done a 90-minute. I've done 30, 40, 60, and then 3 hours. So hopefully I'll figure out the pace. Coming from New Jersey, sometimes we talk a little fast. I'll try not to go too fast. Tim Spann. I do a lot of things in the New York, New Jersey, and Philly area with data and AI. I do a lot of different meetups. I've worked at a number of data companies and going to be working with a new one very shortly. But you'll find that out if you join my online community soon. So I'm on Twitter. I forgot to update my Blue Sky here, but it's the same thing. If you look for PazDev, you'll find me in Blue Sky as well, which hopefully we can all get off of X Twitter. My blog is at datainmotion.dev. I try to cross link everything there. I have a Medium. That's where I usually put the longer form articles. Uh, right now, my position is senior sales engineer. I've been developer advocate. I've done a lot of different things. I like to code, like to write articles, videos. If you have things you'd like to see more of in any of those icons on the bottom, definitely reach out. Again, we do have time now. Always have time later. I'm always putting up new articles, new examples, all those sort of things. And if you have any questions on some of this tech I used to work with, just let me know. So I do a newsletter every week. You could sign up, or you can just view it. I have all the newsletters I put in GitHub as well. I kind of federate that out to a couple different places, just in case you like to do Dev.to, or you want LinkedIn, or you like it on a blog, or you like it a hash node. a bunch of different places. Again, probably should build a tool that federates that out, but some of these media sites don't like you to do that. But we cover open source data, AI stuff, Python, large language models, Gen AI, and just interesting tools that come out, and different things that I've done during that week, and as well as any news that looks exciting, like for next week. Obviously, there's going to be stuff on Amazon. There's some new models out. There's some interesting things going on. So this is the general idea of the agenda. And again, if you want things to slow down, speed up, move around, we got plenty of time. So for once, I'm not worried about not making it to the end. So we did our introduction. We'll do some overview, go through some architecture, then walk through the build, go through examples. We'll see if we can run things real time. In theory, we should be fine. I can touch my server from my hand, not using the cloud today, just to keep the demo on our side. This is the general architecture for this particular one. Now we're just going to look at one of these feeds just to keep it a little simpler, and also go through the simplest RAG, which is grabbing document, boom, it's set to go. But in this one, we're doing air quality readings from REST. We could also use local sensors, and I've done those before, and I've got a bunch of those floating around. We'll probably do that in a further one. Again, if you're interested in doing or where intersection of IoT, real time, AI, and RAG come together, we'll do that. But we'll grab data from OpenAQ, use Python to get that into Milvus, and then once we have it in Milvus, we could federate that elsewhere if we wanted to, and we do that in some of the other examples. But we also send out some of our data to Slack, and then our RAG will interact with this context stored in Milvus and use that as part of the prompt that we send to an Ollama hosted model. Now, we'll get in some details about different models and why I chose a particular one. I've tried a bunch of them, and you might see this that some models work better with different things than others. For some reason, Llama 3.1 is really good at working with reports on air quality. I tried Llama 3.2, I tried Lava, I tried a bunch of different ones, but that seems to be the sweet spot for building a RAG. So we'll go through that. So let's build it again. If you're trying to follow along, now's a good time to either go into a Google Colab notebook, get your Jupyter notebook running somewhere, whether that's on your laptop or the cloud or a small server you have. I've tried it in all those environments and they work. You could even get it working on a Raspberry Pi 5, especially if you got an 8 gig one. I got a NVIDIA over here with enough RAM. If you've got 4, 8, or more gig of RAM, you should be fine. So if you don't have that installed, I mean, it's very easy with Python. I recommend probably at this point Python 3.11. Any newer than that, some of the libraries haven't caught up yet, which is unfortunate. And any earlier than that, some of them aren't ready. You might be able to get away with 3.9 or 3.10. I'd recommend probably 3.11 seems to be the sweet spot. I usually use some other tools to optimize that, and I'll show you which ones I chose. But there is a lot of options. So we're going to acquire sensor data, and again, lots of options there. Connect to Ollama, which if you haven't used that before, there's certainly other options, but Ollama has a lot of the new models. It's very stable, very easy to add different models there. Works pretty well. I'm very happy with Ollama. We install a model. Like I said, Llama 3.1 seems to work really good for these reports. I tried Llama 3.2, various versions. Didn't give me as good results. I'm not sure what's going on there, but we'll see. We'll create our rag flow, run it, try a couple of things, show you where we can change things, show you where we can have options. So really, why do you do this? And I did a talk in down in at the open source summit down in one of the Carolinas, and I talked about all the different rags because there is a lot. And this is certainly the simplest, but for basic usage, you can get a lot out of this. We're going to use the RAG principle, the retrieval augmented generation, which just means grab some stuff, put it in a context in your prompt, send that to your large language model so that the large language model works with that data. And having that in a vector database means it's very easy to retrieve and it's very fast. Now, with sensors, depending on the type, I mean, we could add a function and have a agent go out, ping that particular endpoint, get that current value, then put it in and make that as part of a flow. And that is probably more optimal if you're looking for the current value or you don't know where you are. Maybe you're trying to support a lot of users. Then you could probably skip storing it and you might be able to optimize that, get that data, process that. I've been thinking about that one. Again, that makes sense in the case of immediately grabbing it from a device, locality, supporting a lot of users, maybe tapping a Kafka stream of this data, lots of options there. But we're going to keep it simple. We use RAG, put data in the vector database, pull it out when we need it, build a prompt, get better results. Now, we don't have to do chunking in this sensor version because the data is smaller than usual. Again, there's going to be people questioning, should this even be RAG? Again, the function thing makes sense with this sort of data. So we don't have to do the content extraction. I grab the sensor, uh, combine it in a way that makes sense, put some extra fields in the vector database, and then embed it and have it stored. We don't have to do the chunking or munging of the data. If we do PDF, and we'll walk through the basic version where we do some chunking because you have a big PDF, you're not going to put it all in one row. That'd be slow and not optimal. So you chunk it up, and chunking is 3 or 4 talks there. So again, each step of this we will gloss over and do it the simplest way, but realize you can optimize how you get data, how it's extracted, how it's chunked, pieced up, embedded, so many embedded models to choose, and where you store it. There are a lot of different places where you could store the data, and almost anyone supports vector storage now. And some of these things may not need vector, depending on what the data is. If it's big chunks of text, it probably should be a vector. So when I'm doing a query, I take the query from your prompt, and we'll show you one like, hey, what's the current air quality in Trenton, New Jersey? And that'll be embedded into a vector and use that to do a semantic search and find things that semantically match that super fast. We get our data back. We use that to build up a context to go along with my original prompt, send that to our large language model, and we get a response. We use that for display. If I was connected to something like Discord or Slack, which we do, I can have the prompt start in Slack, consume that, grab our search, build the prompt, call the model, and send that result back. We're just going to do this simple in a Jupyter notebook. We're also going to push some of the data to Slack just to make it easier to display and keep it for future runs, and for debugging. But this is all you need, really: some data, store it, query it when you need it, use it to get the right results. Because when you give the language model the right prompt with the right data, it gives you much better results. It doesn't hallucinate as much. You're it depends on what data it is and what question, and sometimes, I don't know, the models get tired or something. They have some of our human flaws because they were trained with human data, and a lot of it from Reddit. And if you've been on Reddit long enough, you're going to see some interesting results. So, what is the data? We're looking at OpenAQ, which provides open data, which is awesome. Tell you what's going on in the world with air quality. They have a REST API, which we can call with Python. Again, PyData. There's other options, but today we're at PyData, so why not use Python? And this OpenAQ air quality data is everywhere. I mean, there's a lot of people who have pushing up their data publicly to share it with the community. And I have some air quality sensors and I push them up on occasion as well, especially if the air quality is going bad, like we had last year with some forest fires. And we get our location, which is really big for IoT. I want locality, whether that's a lat long, a zip code, some other way to identify where you are. As much location data as I can get, very important because a lot of this data matters because where it is. Also, if I'm going to ask a question, I'm probably asking it for a location. Now, I could have a roll up go, what's the average air quality Earth or the United States? But not as not as interesting. And then the time, what's the most recent one? Someone might go, hey, what was the air quality last week? Depending on how much data we want to store. Again, this is where the difference between we did an agent that'll get right now versus getting historic data. Historic data may not be available online or might have a charge, or you might have to get that out of a marketplace. If we store that in our own data store, whether that's a database, cloud data lake, wherever your cloud platform is, some data platform, you could do that. Main important reading is the sensor readings from all these remote sensors, where they are, what it is. If you have that data, you could do a lot of different apps and you could store them anywhere. So, how do we do this? We're going to make that REST call. We're going to use Python. We're going to put it in vector storage and using embedding models to get it in there. Now, I've shown you some AI graphics before. These are my real cats. These are not AI. Just so we have disclosure again, same here. So when are we going to do this? We can run this continuously if we're in a production environment. And that's when you might decide, well, if I've got a Python app, am I going to deploy it on Ray or in something like Snowpark, or maybe have Airflow batch running, or maybe run this uh, as a processor within Apache NiFi Datavolo, or I could have a cron job, or I could just leave this continuously in a loop. I can, run this in some Kubernetes distribution and maybe in a Docker container. There's a lot of options here. Or I could do something like Flink or Kafka Streams. Lots of options. We are doing this simple, and we're going to get back the data that's recent because I'm not storing everything in the world. I'm running this on an old salvage server that I got. So, what's the key difficulties here? What's our challenges? What's keeping us up late at night if we're trying to do this? There's a lot of data. Like even looking at a subset of this, I'm pulling in 100,000 rows, and some people promote their data every second. And it could even be more readily available if you're running your local sensors and you start getting this from all over the world. There are a lot of sensor readings, and there's some unstructured text with it based on descriptions and what else is going on. There's geospatial data there. It's time series as we get new data, because this is real world devices giving us real data. Sometimes it's sparse. Sometimes things are offline. Sometimes data is not available. This is definitely not what most models have been trained on. This is not near or in the large language model. Again, why people might say maybe this isn't the best data for this, but I have it and it's working. So I guess it's pretty good. So we have the unstructured data. Now, there's also other unstructured data related to this that we could start adding to the system. And I've got other examples of that where it's traffic cameras, there's pictures of the sky, there is videos of the air quality, there's logs from different systems, maybe from these sensors, audio, email may have relevant data there, and things could be need to be in multiple languages coming in, coming out. So we got to handle that, and we could solve this with vector embeddings with the unstructured data part. Now, if we did need to activate, and we go back to that. Now, I kind of glossed over this, but there is a lot involved in doing a vector embedding, and we'll go pretty deep on that. But right now, we'll table that. Again, if you have a question or you want this to go faster, definitely get back to me and let me know. We can go pretty deep in that, and I could show you where you could look up a lot of different embeddings. I've been playing with some of the smaller ones because they run better. There's a new one from Snowflake Arctic Embed 2, which is under a billion parameters, so it's not as huge. I'll show you some of the ones we're using right now, and they're bigger than that. But if we did want to do the continuous ingest, this is an example. So we get REST feeds from all these public ones, plus my sensor that's sitting over there somewhere that's grabbing some of the air quality readings for ozone, different particles. If you remember when people were always wearing the mask really was designed to filter out these air pollution particles. These KN95s are trying to filter out 95% of those particles, which is, different pollutants, different gases in the air, and we can measure those. Now, to get them continuous, we can have different agents grabbing these data and pushing it to Kafka. Now, they could also be, uh, we could have NiFi pulling from these different and pulling them to get the data, and that will run continuously. Iceberg is a great place to store this data for long term analysis. Again, you may want to look at historical trends and run some regular machine learning with Python on that, since you got your Jupyter notebook up anyway. So we have that going into Kafka, and that could be running whoever supports Kafka, whether that's Cloudera, Confluent, Red Panda, Stream Native. Lots of cool companies out there doing this. So you run it yourself in open source, and then that's continuously ingesting it. If I want to do something to it, I can use Flink SQL to continuously run queries on it, do aggregates, push that into other destinations, whether that sync is a Kafka topic, Pulsar, HBase, Iceberg, Kudu, tons of different ones. Another production option is to use IBM Data Prep Kit. This is a new Python open source library that I've been exposed to through the AI Alliance, and it is pretty nice. It's performant and has the advantage of you could start off just running locally in your Jupyter notebook or in a Python app, and then very easy to deploy it on Ray. So you could have a fast Python ingest. Again, that might be your best option if you don't already have Kafka or Flink or some other data architecture available. Now, where are we storing this? I like the idea of a tiered sensor storage. Now, Amazon just updated S3 to work better with tables. So this really says that Iceberg may be the best option there. You've got unlimited storage in S3. Iceberg makes it readily available for a lot of different consumers, whether that's things like Trino and Presto and Hive and Snowflake and a ton of other consumers, Kafka, Flink. Iceberg's a good choice. Redis is extremely fast and in memory. That is a good source for where you might want to store your IoT stuff, especially depending on how you want to get that out. Pinot's another one. again, depending on how you want to consume this, what's nice is once we get into something like Kafka or NiFi or even Python, storing it in multiple locations, federating that out when it comes in is pretty easy. You might want to just drop it into object storage and let people consume that when it arrives. There's lots of ways to automatically trigger that. Amazon has ways, things like NiFi and other systems have way to know when something arrives and is available in your object storage. So you can start with, cheap, abundant storage and go all the way up to in memory, depending on your need, or in stream in Kafka or Flink. Now, we want to ingest today's data. Makes sense. Again, there is some of the historic data available depending on which API we go to. And that's just something you need to do. Now, if you want to get data that we're doing today, go to openaq.org and you could sign up for a free key to be able to access the data. And we put that in our environment variable so that we can pass that as a header when we do our REST call. If you don't do that, you're not going to get data back. So that is definitely a gotcha. Make sure you get your key, make sure it's there. If something's not working, output that variable, make sure it made it through. Sometimes you got to restart Jupyter or make sure that's in your environmental variable. You'd also hard code it for that first try. Make sure you get it out of there. You don't want to leak that out. Again, it's not a paid API, and it's not as critical as losing some Amazon credentials, but you don't want to leak those things out. Good to keep them out of there, either in environment variable or if you have some environment variable storage, do that. So we get today's date, pretty straightforward, and then we get yesterday's by just getting that delta. We format our request. I just want the US because I'm only processing little. Probably should process even less, but again, today's data from the US, starting at 0, get it, sorting it, grabbing a radius of 1,000 kilometers, and I'm good. Like I said, I'm just going to order it by that date there, and we'll get back our data. Now we can ingest into multiple different data stores, whether that's the Redis vector storage, Milvus, Snowflake, Pinot, PG Vector, Pinecone, Chroma. Everyone has one. So if you haven't found one yet, we're going to do Milvus Lite because we don't need a server, and it just runs right within Jupyter Notebook as a Python library, stores in a local database file. Pretty easy to work with and still supports a decent amount of data. You don't need a server or anything, and the results are still pretty quick. So that's where we'll put our vectors. Now, we need to define what the data is going to look like. Now, when we see that REST data, and I'll show you it, has a bunch of different fields in there, and the fields make sense based on, again, remember that sparse nature. So there's a lot of different sensors out there of different types. So they make it kind of generic, which is good and bad. You might want to set up different tables or collections somewhere for each type of parameter. You might want, O3 ozone somewhere, PM25 for that size particle somewhere else, and PM10. There's like a bunch of them, and you don't know what you're going to get back. Most places, most of these devices have multiple, and if you look at the list, ton of different sensors because they can pick up different things based on what it looks like. If it has like a box like this, it's probably getting a couple. So we have the parameter name that's going to tell us O3 PM25. That's important because we want to know there are differences. Some of these are more dangerous than others. Some affect some people more than others. If you have asthma or something, where large particles may be a very bad irritant, and ozone is just not good for you in general. And we get the value associated with that. That is a float. We got our date. We got the unit. If you have the parameter, you can pretty much imply the units, but it's good they send that. They got a couple other values that come in the REST endpoint. We might as well store them. About analysis, entity, and sensor type. And we just keep them along as extra data in our schema. Now, this schema is specific to Milvus. Other databases may be slightly different, but just to keep it straightforward. Now, an important group of data that comes back, remember, we want as much location data as we can get. So we have a location ID that's mapped to what OpenIQ has, OpenIQ, and then a descriptive location Latin long. If you see Latin long in data, make sure you save it. That is really useful because, especially with something like this, where I go, hey, what's the air quality here? And that also means I could do that to look up other data like weather, like traffic cameras, like a lot of data. So then I can have a way to know what's going on in a region, weather, all that sort of stuff, for a, virtual join, especially if I have an agent call where one agent may get the air quality, one might get weather, local traffic conditions, what's local news, all those sort of things. So make sure you keep that. This is super valuable data. What country it's in, it should be US, but we might make this run in other countries and you might want to change that. So it's good to have. City, sometimes they put that in there. City and location are closer to what humans are going to type. So we'll use that. Very important. Some of these sensors are in moving items like a truck, a drone, a plane, whatever it is. So that's interesting to know that this might change. So that might be interesting. Then some of the important fields. We have the ID. We always want one for Milvus. We set that as primary, and it's auto created for us, but it's helpful for performance and getting data back. Our vector, we have to vectorize the data. This is a generic name. Some of the older RAG like default to having a vector named vector originality, but we'll keep it that way. In Milvus and a number of other ones, you could have multiple vector fields. So we might have more ones here, especially if I had some images from these devices, what was near them. I might put those in other vectors that are for images or are multimodal. There's a bunch of them that could do text or image in the same vector because we're running a embedding model that supports doing both, which is kind of cool. Details. So I'll show you what I'm doing, but taking sensor data and converting it into a vector, um, I put it into a textual description so that makes more sense when we're writing our queries. Again, since I'm building this data, I do that. Details is a common name used for a text string that goes along with the vector in a lot of these RAGs. So we'll keep that naming convention. And I built out a full location. That could be another vector as well, but I thought it'd be nice to have that big text field since I'm putting that in the details anyway. You could drop this out. Again, this is extra storage. Whatever makes sense for you is what's important for you. And then we've got for this one, based on the general size for performance, I'm going to use an IVF flat vector. This is an inverted one for indexing. There are a lot of different ways to index, a lot of options. Based on how much data I'm storing, this one makes sense. When you start getting really huge, or if you got NVIDIA GPUs, this is where decisions are made for performance based on what the data looks like, how big it is, how many you have. You might want to change this. Or if you're in a different vector storage platform, you may have different indexes, something to think about. Again, for easiest case, this one almost always performs well. So just fault to that. Our collection or table is open AQ measurements. It's a big name, but I chose that one. And then we have a an index on the ID. Again, if we're having things in order, especially with time series, why not? Again, if you're trying to save space or you're playing around with things, that's when things start to you make decisions around those sort of things. Do you want to change that? Do you not? Now, before we connect to RAG, we inserted some data. We want to test that it's there and that things worked. So we're going to do a search. Again, depending on what vector database or vector storage you're using, this search can vary. Some of them don't let you pick back what field you want to get. Most have some way to filter it. So we're going to do a similarity search. So I'm taking whatever my prompt or query is, run an embedding model, and that's this model command here. And the details is my matching string. And then I just want to put a filter in it. So what's going to happen is I'll say something like, what's the air quality for, you know, or just like, what's the air quality reading for carbon monoxide? And then here we have this filter that says only locations with an uppercase H in it. Again, that could be other matches. I could also do the lat long. Again, lat long has a lot of variants and there's some geo encoding matching that you could do. But like if I knew this is the area I'm looking for, I could also put the full string and doing a match and not a like. I could add more or less fields here, but just to give you an idea, check the data first. And usually that's doing a similarity search. And of course, this is a useful thing as well. You could skip the RAG because just doing a similarity search gives you back the raw data you want, matching what your query is. Again, depend on your use case. You can play around with this. This is where I usually check things like, if I like this filter, maybe I add a filter to the RAG, and RAG will let you do that with LangChain and some other ones. But just to give you some options. Now, maybe I don't want to search on vectors, and again, you want to just filter things out based on all those other fields we had in the schema. So I can get things based on a location and remember those parameters. PM25 is one of the types of sensors, again, for particles. So I could do that. Again, I made that the collection name smaller to fit it in here. We pick our output field in as many as you want to show. There's also ways to get all the data back and, you know, iterate through it, but that's, I don't know if you want 10,000 values back. And here we just print it out. Again, just showing you test the data, make sure it's in there, make sure you understand it before you start asking questions. This is not the typical RAG where I'm asking based on some document and like, what's the capital of, New Jersey, that sort of thing. So there are a lot of options. And I know some people like LangChain, some people like Llama Index, and there's a lot of new ones. LangChain is really simple, really easy to use. The version keeps changing, which I had to actually update today because one of the imports changed. Again, your version, if you're doing point 2, point 3, it'll probably change before the end of today's thing. These libraries are in flux as RAG and Python and AI and LLM and Gen AI are all evolving at a very rapid pace. So if something doesn't work, you can maybe use an older version or do a quick search online and you'll see, oh, wait a minute, that import moved now. Maybe a field name change. Maybe there's one slightly different step, but it should be pretty close. Now, to keep with our thing of easy, open source, run locally, and run easily, we're going to use Hugging Face for our embeddings model. This all mini LM one is not the newest embedding model. Maybe I'll switch this out to Snowflake's Arctic 2, but this one is pretty fast, works reasonably well. And again, with Hugging Face open source, if you haven't looked at Hugging Face, stop what you're doing. If you're watching this somewhere, pause this, sign up for Hugging Face, and it's awesome. Besides their libraries, they have a ton of open models, open source models, some with some license you got to check out first. Be careful on those. That you can use for a lot of things, whether it's for embeddings. They have their own libraries to do pretty cool stuff. But for LangChain for RAG, this is a good option. Then we'll connect to our vector store. LangChain supports all of them. So if you wanted PG Vector instead or something else, just find the one in their documentation for the version you're using. I recommend again use the newest version that you get your hands on. As there's more features, better performance, and they work with the newest models. Like I said, it just keeps changing. So we got our embedding model. We connect that in here, connect to our collection we saw before. Remember, we called the primary field ID, text field details. You can also specify what the vector name is, but we called it vector, so that's default. Same with these two. It'll default to using ID and details. So whether you name it or not, again, that could change in a future version, and all of a sudden things break. Something to think about. And we got our connection args for Milvus. This is just us pointing to that local database file. This could be connecting to a cloud or a local server and may have other parameters for security like token. Depends on where you're running this. We're keeping it simple, free, and open source. So we're running against that file. That's local where we're running our Jupyter notebook. And again, as part of that, we're going to use Ollama. There is a Llama C++. There's a ton now of different ways to run your model, whether that's in somewhere hosted like Snowflake or ChatGPT or some other place, all the clouds. We're going to keep it local and free. Now, it's not as fast. Some of the models aren't as good as maybe the really expensive ones, but that's a lot of the open models are really close now. And for this use case, I think we're getting really good results. So we picked Llama 3.1, and this would just happen to be one of the best open models available at the time that I first started working with this. And then newer ones came out, and I tried them, and this is still the top one, which is kind of amazing. I'm kind of impressed that that's still such a good model for this. But I'll show you how to interact with Ollama. If you're trying to follow along, download Ollama. It is available for most platforms. Pretty easy to install. Now, the thing that takes a while, but it's easy, is installing, adding a model. It's just a Ollama command line command. You do a pull, and you for this one you pull Llama 3.1. It takes a while because it's downloading multiple gigs. As you see the size of these large language models, they have a lot of parameters. It takes a while to download. So once you have that installed and downloaded, there is a Python library to connect to Ollama, and we'll use that here along with LangChain's library. This right here, this command keeps changing, and I don't know if this is the best way to do it. You may get a warning that there's another way to do that. There's some different ways to do callbacks. This is in flux. This works right now. Uh, I'm still debating on this. I'll probably rewrite this in 2025. Maybe we move this to agents. We'll see. I'm trying to keep it simple, easy, open source, using things that you could run on your laptop or run locally or run as cheap as we can. So this right now works. And what this is going to do, it's going to give you a prompt that says query, call it whatever you want, prompt. Set up retrieval to get it from that vector store we set up in the previous thing, where it's that collection we set up. And it's going to use Ollama and this model. So when we run this, there's going to be a little delay as Ollama's waking up. Again, the first one, a little slower, and everything's got to get things initiated and going. If you have more RAM and more CPU, you will be more happy. So then we get the result, and we could do a bunch of different things with the results. We could just it'll just display in the notebook, but we could also store them somewhere. We could cache them. I'm sending it to Slack. Lots of options there. As you can see, this is the screenshot from Slack, and then this my prompt was give me a detailed air quality report for a location, and this gave me this. At some point, I was telling it should format it for Markdown. Slack doesn't show Markdown. I don't know. Maybe I should push it to Discord. I don't know. But just this is just an example. So if you want to see the RAG 101 again, we'll go hands on in a minute here. I'm pushing up imaginary things there. This GitHub here of mine has a walkthrough of the 101 with a documented notebook as an example, where to get the test data, link to an article. There's, I think, video there, all the things you need. So if this looks too complex, this is the 101 with, here's a PDF, chunk it, do the RAG. Really simple. Again, you're going to want Python 3.11 probably. Jupyter Notebook, Jupyter Labs is the best way to go there. Ollama and some model. I again try different models. It depends on what you're talking to and what results you want to get back. If it's a PDF on general knowledge, most of the models work pretty well. Again, for sensors, I found 3.1 for some reason tends to be the best. Now, the tutorial we're doing today is based on an article I did earlier. Here is a link to that to give you all the details, because that goes even further in depth. Screenshots of everything. Gives you all the information you need. Pretty straightforward. Another way to try this out. And again, if you have any questions, if you're here live, put them in the chat or the Q&A. If you're not live, put comments in. I'm guessing this will be in YouTube at some point, or leave it in the GitHub or in one of the articles. I'll make sure I get back to you, and we could do other examples if you want. Now, obviously today at PyData Global, we're picking Python, but there are other languages exist, and there's other ways you could do things. I'm a little partial to Java, and there's ways to do that too. Rust is starting to get stuff, Golang, but all of us will be happy to use Python. All the libraries are there. It is so much easier. The other ones, it takes a little extra work. So be happy we picked Python. Be happy you're at PyData. Hopefully you've enjoyed all the other talks today. There's been a lot. I'm extremely impressed with PyData and the events. The one we did in New York was pretty awesome. So I highly recommend you go to your local ones as well. So we're going to choose a framework. There's a bunch of them, and some of them are easier to use than others. LangChain is really easy. We're going to do that one today. Llama Index is really close which one I want to do, and they're moving back and forth. There's some, I don't know which one. They're both great. IBM Data Prep Kit is newer, has a lot of stuff. If you need to really chunk up documents, do a lot of prep, IBM used this to train their Granite models and get their data prepared. It is nice. I've been really impressed with this one, fully open source. Being able to deploy on Ray is pretty nice. If you have awesome NVIDIA hardware, I can't pick mine up. It's too heavy. If you got NVIDIA hardware somewhere, their NIM for microservices can do anything. It's pretty impressive. And you can even run that on an edge device, put that on your robot. Again, that's not as is free and cheap is what we're doing today. But so we're doing LangChain. We're going to start off. You need to start a Jupyter Lab. You can do a regular Jupyter notebook or a collab notebook or one in Snowflake or some other environments. But again, to keep this open and free and easy, we'll do Jupyter Lab. That could take a while to get that set up, and sometimes you need to change permissions. And I'm running on different machines, so you need to set some IP settings. You might need to change the ports. There's a lot of magic there. Sometimes you can get stuck on that. If you do have questions on that, let me know. I'm not an expert, but I have seen a lot of things break. So I can tell you what, oh, don't have permissions. Make sure you run the right version of Python. Are you doing Conda? You doing UV, something else? But then next step, we're in Python. We pick that. We pick LangChain. We're going to need to connect to Milvus. You're going to need this for search and other things. You may not need this for the RAG, but when I'm doing a RAG, I want to test everything else. So we'll connect to Milvus. Now we're running it locally. So that's the first setting, just a local database file that you inserted that data into. Make sure it's the same one. Now this is a local database. It is not a multi-user database. So if you are loading data and using this one, you can't run the RAG against it. Obviously, that's not continuous, but we're trying to keep it cheap and easy. Uh, if you want have it ingested and used at the same time, gotta move it to a server. You can do that in Docker. Doesn't take too much resources. Gives you a nice UI, other features, faster, more storage. You can run in Docker, or you can connect to a cloud with security, and that runs really well. Again, all you have to change is the what you're pointing to, not too hard. So we're gonna do simple RAG, and like we said, we try to keep everything open source as we can. Calling this the AIM stack. So we got a Llama. Again, I went back before between Llama 3.1, 3.2. 3.2 if you're not doing sensors. That seems to work better with more text data. Milvus Lite is the little local one. We picked LangChain. We're doing Python and Jupyter notebooks. That's our full stack there. If you haven't downloaded that, go there now, download it. Runs everywhere. It takes some resources, but these are AI models. What do you think there? So just go to Ollama.com, download if you haven't done it yet. It's pretty big. It's going to take a little while. So then there's a bunch of different models to choose. If you're doing a regular text one, like most people do, if you want to tweak that to that, this Llama 3.2 instruct specialty version, floating point 16, not too big, works pretty well. You will, when you start this run the first time to test it, it's going to download gigabytes of models and weights. It takes a while, but once you're done, you're in interactive mode. You could try it out, make sure it works the way you want. If it doesn't, remove this one, try another one, and then type /by to exit out of that interface. Uh, Ollama list will give you a list of all the ones you have locally. And as you see, I've been playing around with a lot of different models. You know, Llama 3.2 versus Instruct, different size, different results. Nomic Embed was pretty good. Gemma 2 from Google is pretty good too. Same with Mistral Nemo. Mistral Nemo will do some basic multimodal stuff with images, and so will Lava 7B. Those aren't relevant to what we're doing right now, as we're not doing a multimodal RAG, as that's a little more advanced, but something to think about. That it maybe is your next step after this, or is it agents? I don't know. Maybe multimodal is your next step. Those are a couple good options there. Let's, like everything else, let's import all the things we need. There's a lot of imports. Sorry about that. The Milvus client to connect. Uh, this one I'm going to walk you through before we go into the real code. is that more simple one that's going to do a PDF, split it just to show you that one because that has some more steps. Again, a bunch of things from LangChain. Sometimes these things move, so you might have to change an import. You'll know, you'll get an error. So if you need to, you might have to update those. And sometimes the names are slightly different. Sometimes those underscores become a period. It's something else. Uh, you'll see. Uh, and you can look online and find those pretty quickly. We built for this one. We're going to download some PDFs. Again, the difference between this and the sensor one, which we'll go into next, is we got a load of PDF, and then we're going to chunk those up. Like I said, connect to our local database, create our collection if it isn't there. Up to you if you want to pre-create that and reuse the same one every time. Again, we mentioned the Hugging Face open source, pretty awesome. If it is text, you're going to chunk it up. For the sensors, we're too small. We don't need to make them any smaller, so we're fine. Here, 500 characters. Lots of different ways to break it up, or you're breaking it up on different paragraphs. There are some models that'll help you chunk up based on semantics, which is probably the best way to go. You can also chunk it up multiple ways and store it in multiple vectors, and then try different embedding models like BM25 and a bunch of other ones to figure out how you want to store things. There are a lot of different embedding functions, things like Snowflake Arctic and a bunch of others. There's ones from APIs out there that are usually pay, like OpenAI, and then there's a bunch of open source ones like from Hugging Face and some others that do things like hybrid. This is kind of cool because you can pick sparse or dense. Dense embedding is a traditional one that is big number of vector dimensions that can be like, you know, 1,000, 2,000 or more. And that is usually pretty good for results. Some of these sparse ones, like Splade and BM25, are good for keyword style searches. And again, putting these together in a hybrid search could give you the best results. Again, Mistral, Cohere, Gina, they have a ton of interesting, powerful models that every week there's a new one. Try which one makes sense for you based on your budget, if you want it open source, and your particular data. You may have to play around with this a couple times. Try it, see what the results are. I have changed that a couple of times. Here we're taking all those splits, embeddings, verify they're loaded. Again, using the tried true existing one because I only have a CPU. Let Hugging Face download things remotely. This sometimes pops up as a problem. Based on where you're running in your environment, you may care about this. Your security people may care about this. It's something to think about. Who's embedding from where and how you're downloading it. A lot of these things can be pre-downloaded, so that might be more optional, more optimal in your environment where you are. Here I'm saying don't drop this. Now, if you're grabbing the same 5 documents every time you run this, you're going to want to drop it, get rid of those old ones so you're not just loading more of the same thing. Again, figure out what your data is. So that's what that means. If you set that to true, it's going to drop everything and load that current list of embeddings and documents. If you plan to reload it every time, then do that. If you don't, make sure you set that false. You want to put new stuff in. Pretty similar to our other one. We're using this 3-2 model that works better with prompts. And I called it prompt instead of query. And not much of a difference. And then we have a loop that we keep running continuously in our notebook so that we can run this multiple times. Maybe you only want to run that once. I don't know what your use case is, how you want to run this. Lots of options there. Lots of different ways to automate these things. Now, before we get into the slow walk through the live stuff, I have one that does it with street cameras. This was interesting because we're grabbing IoT cameras, getting those images and vectorizing them as our primary data source. But again, we have lat long again. So we could start thinking of how I want to do all this geo data and, maybe build an app where people can ask questions on what's near them and what's in their environment, what's going on, how's the best way to get around the city, all those sort of things. We'll get back to questions. Again, I'm not seeing anything pop up in our thing yet, and then we'll go back to some resources after we go into the live thing. Hopefully, all my stuff hasn't timed out. It's been an hour here. Usually we get to it quicker, but we got more time today. I want you to see the GitHubs. If you're, I'm not sure if these will be passed along, but if you go to my GitHub, you can see a bunch of different ones here. And we've got more details, and we got the notebook here. We also have the ones for air quality, which is the one we'll dive into. And you can see the examples here, how we load it, and some other examples. There's some variations here. This is in this GitHub, and this has all the features you want. Again, if you're going to use anything, you have to get the API. You got to sign up for it, OpenAQ. If you want to do some of the more advanced things with LangChain, you can sign up for LangChain for their LangGraph. And just to give you some examples, that's there. I've got a ton of other examples. There's that newsletter for you, and a ton of other source code on a bunch of different things with different types of data. So you want to check that out at GitHub. This is that Slack channel I said I'm going to push to, and we can see the last one I ran. Uh, that grabbed data from yesterday, and you can see in a couple days there when it formatted this report. Pretty cool. So let's go into our Jupyter lab and take a look. First, I want to show you something I was running yesterday. You might want to take a look at this one. There's a Google collab for working with RAG, with Milvus and Snowflake. It's embed model, and this is pretty good. This one does need some Kaggle resources. You got to be signed in there. If you haven't joined that, highly recommended. Great source of examples and bunch of things, data. It is a good one to go through, and you could follow this example along. I pasted that one there. Well, let's get into the main thing. Hopefully, it didn't time out. We have been here a while. Now, the thing I wanted to show you here is the seems like the easiest way to work for libraries for me is UV. I don't know if people have seen UV. I think this package manager for Python is pretty awesome, and it is really easy. I mean, I tried poetry and just regular pip, but it is very nice. It seems to have been working really well for me, so that's why I got this UV up here. That is pretty nice way to install things, and it doesn't make it too messy in the notebook. Like it knows it has it there, so it didn't go through any nonsense. Now we're going to take a look at Ollama. I've changed some of the models here, just as some of them I weren't using, so I removed it, installed some new ones. Here we got the new Snowflake embed. There's the Llama 3 one we'll use today. This one is great for the multimodal with image ones, and regular Llama 3.2 for some other things. They just got the new Vision one to run on Ollama. So I'm going to try that and see what's the difference between Lava. Again, in a small, about, actually bigger. This is 7 billion parameters, but look at that space there. Okay, so let's see if we can run this again. I ran it just before the tutorial. just to show you. If you this is going to be loading a lot of data. This may have lockup. Let's see here because I have the RAG one open. It may still be tied to that database. Again, we can't do both at the same time. If that's the case, we'll have to stop that one and go over. It is still running, so we're okay so far. And what this one's going to do is what we showed you before. We create that schema, and then we're going to go. I'm just doing 100 pages. There's different ways to iterate through these. They don't tell you how many they have. I don't know why that's not a parameter. Some other APIs do that, and then you could set how many you're going to have to go through. But here we'll just go through the first 100 because that's 100,000 records, which is pretty good for running locally. Like I said, there's the setter. It's just a regular request get our response with those headers. And if it's not empty, we're just going to iterate through the JSON we get back. This is the part that's most interesting, I think, is remember I said we're building that full location. Well, I'm just building up a big string there for all the location fields, just so we keep them together. And this is where I create a human readable report here, talking about the air quality reading, and we're grabbing the different fields here, the parameter and value, and the location information, all those things there. And then we're gonna get this ready for insert. We'll grab our location, all those fields, so they're in there as well as in this vector, in this detail field, and then the locations there. Then we insert those, and then when we get to 1,000, we print that out. So that's going to keep running. I'm going to stop that so we can use this elsewhere because otherwise this will have a lock, and it still may have a lock depending on what's going on. But see, it went through 90 packages. We had an update. That's interesting because I installed this like a couple hours ago. So that's interesting. So we got a bunch of LangChain, and this changed recently. This was under community moved. That happens. I know we got like at least 20 minutes here, so we're in good space. Let's see if there's any questions. I don't see anything yet. Again, just drop a chat or a Q&A if there's something you're not getting or something you're curious about. So we define those variables. Let's see if we've regained control of our environment yet. We'll run that. We might not. I might have to start and stop our environments here. I don't know if I need all these running here. Again, sometimes I'm on a pretty small box here. Probably shouldn't be running everything in the world, but let's see here. Did we get this back yet? Yeah, we got that back. I am talking to Slack, so you need some Slack credentials for that. If you're curious how to talk to Slack, I've got an article on that. It's pretty straightforward. Create your own Slack channel and create admin. The steps aren't too bad. And then pretty easy to send out stuff to Slack. There's our Hugging Face model. That's the collection name we saw. We saw this before. I'm using this for some improvements on how they run. You could do LangChain without those. Turn off some warnings. Again, we saw that vector store. Let's make sure that one's still connecting. Yeah, see that file is locked. So we're going to have to make sure that that's closed there. And we might have to restart it. Again, the problem of not using the server. We'll see if that was enough to release it or if we've got to restart something. Yeah, we got to restart things. Yeah, what you can do? We'll shut them all down. Not the end of the world. Okay, then we'll, just to be sure, I like to reload whole notebook, make sure things are good. Once I know we got our thing going, and then make sure we're really reloaded, restart that kernel. Make sure everything's running. Yeah, that's looking good. Let's see. Okay, that's done. So that's a good sign. Okay, let's see if we connect now. Hopefully that's yeah. So if again you don't have to go this way, you can connect to Docker or some more production version. We'll get this defined here. Again, we don't have to do that in a loop. We could just run this once. Maybe that's a better way to do this because then I'm closing it and you get all those warnings. Despite me trying to turn off every warning, sometimes you can't. I've been loading. Well, before we start that, let's take a look at some queries. We'll do a search first. Make sure this is nothing matching that search. We'll do a query, and we got a bunch matching. I just searched for new, so it's looking for anywhere with new in the middle. Location matches that, and parameters PM25. So then we'll get those result back. I'm just showing 10. We could show as many as we want just to make sure there's data in those collections. We'll do another one for Trenton, and I'm seeing I'm getting Trenton back. So that's a good option for running a query. I also cached a couple here in a markdown section, so I didn't type a stupid response here. And we'll just run this once without being in a loop, just in case we want to change things as we're going through. Now, this is calling Ollama. This is not fast. This is not fun to watch because, as you see, it takes a little while. I'm running on a small machine, so that's going to take a little bit. We could take a look at, again, that more documented version here. I try to turn off as many warnings as I can just to make the notebooks a little cleaner. But yeah, we run through this. Again, if you haven't installed Ollama yet, definitely do it. It is a great version. We can have a debate VLLM, uh, just a Llama CPP, but this is a very cool group. They do a lot of open source stuff. They're always adding things. And again, there's a couple of new models here, which are really awesome. So something to give you a try. Very easy to set up here. We could also try this version. I don't know if I'm brave enough to try to run two things at once here. Okay, it's starting to come back. Again, it's a little slow because this is not running on a server or something super big. So this is giving me air quality report based on that information stored in the vector database that we loaded from those sensors. And as we saw, we had a bunch of that raw data. This is making a decision what it thinks an air quality report is. And I think it does a pretty good job. Picks this location, gives me all that location data, tells me a reading from yesterday at 7 p.m., which may be the last reading. We've got ozone in here. They're giving me ozone over the last couple of reports. It's gone down a little bit, so that's good. The weather's changed here. Again, this is where I might want to add in the weather because the weather dropped in temperature and now we got some rain and a little bit of snow, kind of a mix. That's going to affect some of these readings. This is where you might want to grab those extra feeds. This is where the thought of do we do an agent? Ollama now supports function calls where I can call, get air quality, get weather. Again, does that take too long? Would it be faster to read that from directly from a rag for the vector database? I don't know. And they have some good suggestions there. That's pretty cool. When I tried it with some other models, it did not generate this nice of a report. It's been I've been pretty impressed with this. Let's see if it'll do this one where I'm asking specifically with PM25. It may not have it in this most recent couple of days. Again, depending on when we run it and what data is available. Again, there's the vagary of what's in the database. And like I mentioned, I pushed that to Slack. Let's see if it made it out there. Yep, we got a new message here. And this was our air quality one that we just had there. And it makes it readily available for us in Slack, makes it a little easier. Now we have, I think I've got like 12 or so minutes left. Let me check for questions. I'm not seeing anything. So I will continue as if everything is very easy and everything's working. If it's not, let me know because otherwise I'll just keep going until we run out of time. I think this might be the last session of the day. And if that's the case, enjoy the rest of your day. I don't know what time it is by you. For me, it's in the late afternoon here in Trenton, New Jersey area, almost 3 p.m. And air quality, see if I can get a newer one and get some air quality. I've got a lot of things I post out here. uh, okay, let's see. I liked how they're trying to make some assumptions on things. Okay, was able to get PM252. Now, I have tried to make it do the report for both. That may be asking too much because sometimes that works, sometimes it doesn't. I guess, sometimes it's touchy. Now that it's run both, maybe it'll run a combined one for the third one. But this is grabbing a couple of different readings. We'll probably run it later today and get some newer data. But what is it now? It's bounced up. This was not good in the morning yesterday. 26, dropped to 12 though. When we had that forest fire, they were in the hundreds, which is bad. So this isn't the worst. And let's see. Do not indicate severe air quality issues. Now, obviously, you might want to take a look at something like OpenAQ directly. They have some descriptions of what they think are uh, weather air quality and which ones are safe. Yeah, if it looks like this, you're probably not good air quality when the sky is yellow. But yeah, this is an awesome organization, and it's awesome to have open data to collaborate with. And I highly recommend you sign up and take a look and take a look on what all these things mean. And as you can see, there's a lot of data around the world where these things are. I'm grabbing them from all over the U.S., but some of my readings are around here. Again, see, this one was updated 2 hours ago, and it depends on which ones they are. Some are run by schools, some are government, some are just people bought an air quality monitor and they want to share that data with everybody, which is pretty awesome. And you can see what their different readings are. See, this one has temperature too. That's pretty good. It tells you what kind of device. Oh, look at that. That's pretty cool. They've got decent number of sensors there. I like that. Just to give you an idea what data you could get. So we got another one sent over. More extensive data at current weather conditions. Again, we should probably add that. That's probably the next one. Air quality plus weather is probably a good mix. We'll see if it can do both together. Now, if you're interested on how to do this one's kind of slow. There's a lot of options here depending on models. I don't know if people want any specific thing shown. This one's going to continue running. I'll do that while we go through some of the other information available. So we did that. We've got to, again, you have these slides out there. Got some more examples on how to look more into the sensors and the different air quality available. This one tells us why you need these extra fields, and it makes sense if you're used to working with structured data just to get all the lat long parameter values outside of the normal vectors. This one is interesting because this is working with just images as I'm doing pose estimation live off a Raspberry Pi. This one we did at the PyData in New York, and this is kind of a fun one. Again, showing you we can go anywhere from sensors to someone moving around in an image real time, depending on what you want to do. We already mentioned the air quality, the weekly thing. I guess we are out of slides. We are almost out of time. Is there? I'm not seeing any questions. Oh, maybe a question. Most accurate chunks. Okay, that is a really good one. Okay, let's see if we could pull one up. Now, what I'd recommend is to get the most accurate search. Depends on how accurate you want. When we're storing in a vector database and doing similarity search, unless you choose a completely flat index, the index works by approximating. So if you want 100% accuracy, there is an index for that. It is really slow because when we do a semantic search, there's a number of different ways it does it. There's a number of different ways it goes down the paths and the trees to find stuff. If you want 100% accurate, it's got to go down every single path. If we all remember from computer science, walking a tree every possible path is exhaustive. So once you have a ton of data in there, it is going to be a very unhappy situation. But that doesn't mean we have to do that to get super accurate data. We can get super quality results, getting exactly what you want by doing a couple of things to make things better. Now, this does vary based on what vector database you have, what embedding model, how you set things up. But I'm trying to find you an example here when there's too many examples to go through. What I'm looking for is to show you a hybrid search. Why you want to do a hybrid search? One of these has the hybrid search. There's too many things here. Maybe this one. Try to find that as fast as you can. Now, the first thing you can do, and I recommend this highly, is use a filter. It is the easiest way to limit it. Did this finish? Yeah, I finally finished. So we can go to here. This is a filter. This is exact. So if your vector database supports that, use that filter to limit things to the best thing. That's why we put those extra fields there. Like if you want to get the result of a document and you know that it's from this particular document part, or you know some other field there, put those fields in, that'll filter it. That gives you a closer match. The second thing is to make your prompt or your search as close to what you want as possible. Like here, I'm doing partial Trenton. Now, if I know that it's just Trenton or it's some long string, like if it's Texarkana, New Boston, well, you know what I should do? I should search where it's, get as limited as much as possible to get it to that. So I'm not, no, maybe that doesn't have an O3. Okay. Yeah, that one doesn't have an O3. Yeah, just PM25. Make it as close to what you can there. Filters number one. Number two is to do a hybrid search. Now that's where I'm usually going to combine multiple vector fields along with probably a filter. Let's see if we can get to that one. That's way down here. This one has cats, so it's a little cooler. No air quality in the cats. If you have cats, you probably don't have good air quality because they have a lot of cat hair. So we go through that. So filter number one, use a good indexing model, use a good embedding model. When you chunk things up to insert it, use the best chunking algorithm you can based on what your data looks like. If you have generic PDFs, maybe use IBMs, maybe use unstructured, unstructured. There's a lot now that depending on, do you care about embedded tables in there? How is this data embedded in there? There's a lot of options. This one does not have, cats trick me. Unfortunately, I'm trying to find my hybrid search one that shows you, in depth how to do the best queries or hybrid search, and trying to find that. We will try. This might be in this one, in the ghost one. Doing a hybrid search, I'm going to do multiple searches against possibly multiple vectors in your store using different options, combine those searches, and then run a re ranking algorithm to give you the optimal possible results from multiple searches in one. Is that a little slower? Yeah. But is it giving you better results? Probably. Again, use the best embedding model, use good proper indexing, tweak your prompt as well as you can. Let's see if we can find this hybrid search here. Okay. Yeah, here's our hybrid search. And we have five different requests together. And then we connect them, use a re ranking algorithm, and sort it by the closest possible result. And that makes things a lot better. See if I have the code here. It's so many notebooks. Let's see. Is that in the rag? Or is that in the? I think that's in the analytics. Yeah, it's not Halloween anymore, so I kind of forgot about my ghost hunting stuff. Okay, let's find that one. If you look here, I'm using multiple models, sparse and dense ones, to try to encode the data multiple ways. Now I'm doing a search of images. It's the same for text. And here I want to find a ghost with a skull head. You do what you want to get. So I get those results back, and then I have a regular search here that's just doing one, but let's do the hybrid. So that is, I'm using one embedding for one search, and I'm searching by text, and I'm searching by an image. So I've got both encoded. I've got another way to do the text search, and that one is sparse. And then we search splayed as another sparse one. Then I'm grabbing an image using that to search. Then I'm doing a dense search with a different algorithm, the BGEM3. And then I combine all of those, throw in my re ranking algorithm, and get back a higher quality, closer result. And that is the way to probably do that the best. Again, start off with the cleanest data that is close match as you can. Again, there's a lot of different PDF processors. I listed a couple of the new ones in my newsletter. You might want to check that out because that makes a difference. If it's chunked the best way semantically, it'll give you the best results, and you could use an LLM to do that. There are some LLMs that'll process those chunks semantically best. We are, I believe, out of time. So thank you. And see you again, hopefully next year.
Yes, thank you so much, Timothy. For all of our attendees, thank you for participating and asking questions. If you'd like to see the recording of this session, it will be made available as soon as the session ends. If you have any additional questions or want to continue talking, please feel free to use the PyData Discord channel, which is available in the reception, and also the lounge feature for those small group discussions. But again, thank you so much for hosting this tutorial, and thank you for attending PyData Global. We'll go ahead and close out this session.
Thanks, everyone.